Hi, Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone. Today we're going to continue our discussion on topic 5, function and graphs. So we're now in lecture 3 of 4 with 5.3 inverse function. Okay, so I do hope that all of you get ready with your lecture notes on your hand right now. Okay, so at the end of this topic, students should be able to identify whether the function has an inverse and find the inverse of the function. Okay, whether the function has an inverse and find the inverse of the function. Then compute the inverse of the function. We're going to find out what is a function and find the domain and range and sketch the graph of the function f and its inverse. Okay, sketch the graph of function f and its inverse on the same axis. Okay, so a function f is one-to-one function. A function of f is one-to-one function if fx fx1 equal to fx2 implies that x1 equal to x2, which I think that we had discussed this earlier of the topic, lecture of 5.1. An inverse function of f exists if only if the function is one-to-one and onto function. So what's the meaning of all this? So now, for example here, so we're going to find out whether this function is a one-to-one function or not. So fx1 equal to fx2. So then it is 3x1 plus 2 equal to 3x2 plus 2. Okay, so it's either we minus 2 on left side, on right side, or just bring this to the other side, become negative 2. It's up to you then. Okay, minus 2 and minus 2. So 3x1 equal to 3x2. Divide by 3 left and right. Okay, 1 over 3. And also here, 1 over 3. So then it is x1 equal to x2. Thus, fx1 equal to fx2. So fx is one-to-one function, and this function of fx has an inverse. Okay, now algebraic approach. Okay, so I'm solving this using algebraic approach. Okay, so now for fx equal to x squared plus 4x plus 1. Okay, so where x is an element of real numbers, so let fx1 equal to fx2. So x1 squared plus 4x1 plus 1 equal to 4x2 squared plus 4x2 plus 1. So then, again, we minus 1 left and right. So x1 squared plus 4x1 equal to 4x2 squared plus 4x2. Okay, now we bring all this. So we're going to bring all this to the left side. x1 squared plus, oh, sorry for you. It's no 4 in here. Okay, so bring this to the side, to the other side. So x2 squared plus 4x1 minus 4x2 equal to 0. So from here, it's supposedly negative. Okay, so from here, we come up with x1 minus x2 and x1 plus x2. Factorize this, then you get this one here, plus with factorize 4, take it outside, then we get x1 minus x2. Okay, so then with this, which I think that, okay, so we have x1 minus x2 and also x1 minus x2. So we factorize this x1 minus x2. So factorize between these two, then the rest of it, we put them x1 plus x2 plus 4 equal to 0. So from here, we have x1 minus x2 equal to 0, x1 plus x2 minus plus 4 equal to 0. So then x1 equal to x2 and x1 equal to negative x minus x2 minus 4. So there are two values of x1, which is x2 and negative x minus 4. Okay, so meaning it's not a one-to-one function. There are two values of x. For the two values of x, possible value of x, which is x1 and x1 here. So then fx is not a one-to-one function, then meaning that fx has no inverse. Okay, so then okay, so from example 1, it is fx is a one-to-one function, but now example 2, fx is not a one-to-one function. So then fx is not a one-to-one function, so we conclusion that fx has no inverse. Okay, so if a straight line that is parallel to the x-axis is drawn and is at most cut the graph at only one point, then the function is one-to-one. So graphical approach, which I think that we have seen this before. Graphical approach, if a straight line that parallel to the x-axis, we know that we have an x and also y. So now, if there is a straight line that parallel to the x-axis, meaning a line of this, for example, parallel to the x-axis and in cuts, and it most cut the graph at only one point, then the function is one-to-one function. Okay. So now graphical approach. Okay. Sorry. Okay, y and x-axis. So as we know that x minus 2 x minus 2 can only be greater than or equal to 0, then we get this one. So class, actually that automatically this is the domain of the function f. Again class, if they give you a questions and additional information here where x is greater than or equal to 2, automatically this is the domain of this function. Okay, so the domain, if they ask you what is the domain of this function, the domain is 2 to positive infinity. Okay, the things here now is we are not going to discuss on the domain here right now. We are going to find out whether this graph is one-to-one function or not using graphical approach. So there's a y and x axis here where x equal to 2. Okay, so now if I make a recall one straight line that parallel to x-axis, horizontal line. Okay, how many point, or that we call this line, the purple line, cut the graph of this function of fx? Only here one, right? Okay. Okay, let's say we try it again. What about here? at how many points that this line, this purple line, cuts the graph? Yes, at only 1 point here. Okay, what about here? 1 point only. What about here? 1 point only. Okay, so from this picture, it shows us that this is a graph of one-to-one function. So, okay, the line drawn parallel to the x-axis cut the graph at 2 points. At 1 point, sorry. At 1 point, cut the graph of this function at 1 point, thus fx is one-to-one function and has an inverse. Okay, so let's see next one. Okay, so class, let's say fx equal to x plus 3, and then let's say when x equal to 0 and when fx equal to 0. So then f equal to, when x equal to 0, f0 equal to 3, and when fx, which is x plus 3, equal to 0, then x equal to negative 3. Okay, so let's find out now this one here now. The coordinate of 0 and 3 and negative 3, 0. First one here, 0, 3. 0, 3 and negative 3, 0. So make a line. So this is fx equal to x plus 3. But that, by the way, okay, but then the function that we're looking for here is fx equal to absolute values of x plus 3. As we know that this value of fx or y will always positive for all values of x. The value of fx or y is always positive for all values of x. So, on this graph, it tells us that this graph from negative 3 to negative infinity, especially the one that below here, below the axis, the graph that below the x-axis is all the y which is negative. So we are going to, okay, for this part only, we are going to bring this above, shift the graph or reflex through the x-axis above here. Okay, sorry. So then we are going to clear all this. There you go. So there is the graph. There is the graph of absolute values of x plus 3. Okay. So now let's sketch this line of red line parallel to x-axis, and we will see at how many points that this red line cuts the graph. Okay, it cuts here and also here, meaning there are two values of x, x1 and x2 to the one value of y. Okay, so this is many to 1. So then a line drawn parallel to the x-axis and cut the graph. At 2 points. Okay, here and here. So thus fx is not a one function and has no inverse. Okay, so that's it. Graphical approach. Okay, f inverse function of the inverse of the function. Okay, we now get into we call the beginning of the discussion to find the inverse of function. So if fx equal to y is one-to-one function, therefore the inverse function is denoted by f inverse exists with f inverse of x, f inverse equal to y, which is y approach we call map to the x. Okay. So now let's say let fx equal to 1 over x minus 3. Okay. So class, in this case, we are going to change this fx, fx in a term of y. Y equal to 1 over x minus 3. So then right now, class, this fx in a term of x. So we change it into y. Then this is y equal to n fx. So we're going to come up with x equal to f inverse of y. Okay, so from here, y equal to 1 over x minus 3. Okay, cross multiply x minus 3 multiplied here, x minus 3 multiplied with y equal to 1, then x minus 3 equal to 1 over y. Okay, and then x equal to 1 over y minus 3, or make this one, simplify this as 1 minus 3y divided by y. Okay, so then f inverse of y equal to 1 minus 3y divided by y, or f inverse of x equal to 1 minus 3x divided by x. Wait a minute. Okay, x minus 3, y, 1 here. Okay, divided by y. Okay, negative, bring it here because supposedly positive, sorry. Positive, 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 and positive. So this is how one of the method to find out the inverse of the function fx from fx equal to 1 over x minus 3, then the inverse function of this fx equal to the inverse function f inverse function of x equal to 1 plus 3x divided by x. Okay. Using the properties of f(gx) equal to g(fx) equal to an x, okay, implies f is the inverse of the g, or g is the inverse of the function f. So class, the composite function, composite between the f and its inverse, or the inverse of f with its fx, will straightly give you a function of x. Okay, so let's try on this. Let's try with this definition here. Let's try with this one. Okay, now I will try this. Okay, I do believe that all of you have copied all this, so I'm going to use the fx and its inverse just to prove to you that the composite function between the f and its inverse will straightly give you an x. So class f inverse of x, Okay, let's see. F inverse equal to 1 plus 3x. 1 plus 3x divided by x. Okay, this is my call an extra explanation from me. Okay, never mind. And then substitute all this into an x of the function f, which is 1 over 1 plus 3x divided by x minus 3. Okay, so we try to simplify the denominator here. 1 divided by, just imagine that because 1 plus 3x, we have an x here, denominator of x. So just imagine that we have an x here and x here. So 1 plus 3x minus 3x divided by x. Then 1 over, okay, now 3x minus 3x equal to 0. So we have 1 over 1 plus x. So bring above here, switch the position upside down, and then it's going to give you an x. Okay, so then composite function between f and its inverse will straightly give you the result, which is only an x. Okay, so we are going to use the property here, the domain of f. Okay, so we have domain of f and range of f, domain of f inverse and the range of f inverse. So the domain of f is a range of f inverse, and range of f is a domain of f inverse. Okay, there you go. Okay, this based on we call which can one. So find the inverse of this function fx. So then f and f inverse of x equal to nx. Okay, so just imagine that if we use the definition to find this, we are going to substitute this function of f inverse into an x of the function f. Again, a composite function, the process of composite function is where we substitute the function inside, which is f inverse, substitute this into an x of the function f, which means that we come up with now 2 f inverse of x plus 1 equal to an x. Okay, so now bring this one to the side. 2 f inverse of x equal to x minus 1, and divide by 2 left and right. So then f inverse of x equal to x minus 1 divided by 2. Okay, and then the graph of f inverse n is the reflection. The graph of f inverse is the reflection of the graph of f on the line of y equal to an x. Okay, so for this one here now, class, for this case, sorry, wait a minute. Okay. There you go. Okay, and y and x. So reflection on line of y equal to x. To sketch the graph of f inverse and f. What happened to this? Oh man. Okay. So because before we sketch the graph of f inverse and f on the line on the same axis of y, okay, or on the same axis, we are going to sketch the graph of y equal to an x. Y equal to an x is a line that divide this quarter into 2, where the angle between this line and the x-axis is 45 degree, and also here 45 degree and 45 degree. Okay, the degree is not the subject here, but then just to tell you that the line of y equal to an x is at the graph as you see on screen here now. Okay, now the graph of fx equal to 2x plus 1. Okay, so when x equal to 0, then f0 equal to y equal to 1. And when y equal to 0, the whole of this function equal to 0, then x equal to negative 1 over 2. Okay, so let's find out now 0 and 1. 0 and 1. Then negative half and 0. Negative half and 0. This is 1 and here is negative 1 over 2. So make the line. Okay, sorry. Okay, this one here. So this is f, which is 2x plus 1. Okay, as mentioned here, the graph of f inverse is the reflection of the graph of f. Reflection, okay, of the graph f on the line of y equal to an x. So then, so just imagine that if we bring this negative half here, negative 1 over 2, and 1 bring up here equal to 1. So then, okay, it's not very straight line here, sorry for that, but this is it. There you go. So this is f inverse, which is what's up? X minus 1 divided by 2. X minus 1 divided by 2. Okay. Okay, so example 6, find f given fx equal to square root of x plus 2, find f inverse, sketch the graph on the same axis, and determine the domain and range for the function f and f inverse. Okay, so now, let fx equal to y equal to square root of x plus 2. To solve or find the answer for the first question, to find the inverse, find f inverse. Okay, so we square left and right. So then we get y squared equal to, clear this 2, and we get x plus 2. Then x equal to y squared minus 2. So then f inverse of this function equal to x squared minus 2. Okay. Okay, if you refer to this question, recall the examples in your lecture notes. So then the second question here, sketch the graph of f and its inverse on the same axis. Okay, now. Okay, and this purple represents the line of y equal to an x. Okay, this is y equal to an x. So now, for this graph, this is the domain x greater than or equal to negative 2, meaning the graph will begin at here, negative 2, and Okay, might be not something like this. Okay. Okay. Then the inverse of this function, 2, -2, and -2 here, and so the red line, this red line represents the f inverse, and this blue line represents the fx. And there you go. Okay, now what is the domain of this function? The domain of f, this is the domain here from -2 to positive infinity. The domain is what we call -2, positive infinity, and the range of f equal to, okay, refer to this graph of fx. The domain is from -2 to positive infinity, and the range, okay, y equal to 0, and the graph is all above the x-axis, meaning the range is all positive y or positive here. So this now is 0 to positive infinity. Okay, what about the domain and range of f inverse? Class, in this case, you don't have to think much about how to, okay, by looking at the graph of this red line here, as we know that the domain of f is the range of f inverse, and the range of f is the domain of f inverse. So the domain of f is also the range of f inverse, which is, yes, -2 to positive infinity. And the range of f is also the domain of f inverse, which is, yes, 0 to positive infinity. There you go. Okay. Okay, let's see with the next example, sketch the graph of f inverse on the same axis for this one, which I think that I show you all of you here to find the inverse, to sketch the f and inverse on the same axis, and find the domain and range. Okay, using the properties, which is something like this actually. f inverse of x equal to an x, okay, square root of f inverse plus 2 equal to an x. So square left and right, and we get f inverse of x plus 2 equal to x squared, then f inverse of x equal to x squared minus 2. Okay, class, for me, I love to, I prefer to find the inverse of this function f using this method compared to this method. Okay, but you have a choice to find the inverse, whether to use this using the properties f and f inverse into an x, or you can certainly using this one here. Okay, you make a choice. Now fx equal to x squared plus 2, find inverse, sketch the graph, and determine the domain and range of f. Okay, let's continue. So this is a function here now, so let y equal to fx. Okay, so then x equal to f inverse of y, and then y equal to x squared plus 2. Okay, so from here we try to make it as an x equal to a function of f with a variable of y here. So x squared plus 2 equal to a y, and x squared equal to y minus 2, and x equal to square root of y minus 2. So then f inverse of y equal to square root of y minus 2, or f inverse of x equal to square root of x minus 2. So this is a function of fx, and this is the inverse function of f inverse of x. Okay. Okay, so then, okay, class, square root of x equal to square root of this is supposedly they have a positive and negative. Okay, because square root of square root of 9 will give you positive and negative 3. Okay, square root of x equal to a, then x equal to square root of a, positive and negative. It can be positive, it can be negative. But since that the x is greater than 0, so we are taking the positive value of inverse only. So there is no negative, but only positive square root of x plus 2. Okay, now, to sketch the graph of f and its inverse on the same axis. Sorry. X and y. Okay. And the purple represent the line of y equal to an x. Again, this is y equal to an x. Okay, now, the blue ink represent the x equal to x squared plus 2. So we have here, okay, class, actually that this is the graph. Okay, the proper of this graph is x squared plus 2 is a curve something like this. Okay, but since that we limit the domain of x greater than or equal to 0, so there's only this graph. Then we erase this part here now. So this is the graph of x squared plus 2, where x greater than or equal to 0. So from here to, yeah. Okay. This is the function of f. Now, reflects. Okay, f inverse is reflects to the f with the line of, from the line of y equal to an x. So let's say y equal to 2 here reflects with this line. It is x equal to 2. And the graph, sorry. There you go. And this is the f inverse. Get it? Okay. Now, the domain of f and the range of f. So domain of f here, domain where you can see is all values of, okay, this is automatically the domain of the function, which is 0 to positive infinity. And the range of this function, where you can see the graph is all mapped to the value of y, which is above the 2 here. There is no graph of fx below this. Okay, so then the domain, we call the range is 2 to positive infinity. So what about the domain and range of f inverse? Again, we can just simply come up with the conclusion that here the domain of f is also the range of f inverse, and the range of f is a domain of f inverse. There you go. Okay. Okay, so now the last one here. Again, the same question, find f inverse, sketch the graph on the same axis, and determine the domain and range of the function f. Okay. So now, let fx equal to y. Okay, and then x equal to f inverse of y. So the first one here, make this one as a y equal to 2 divided by x minus 1. cross multiplied x minus 1 multiplied with y equal to 2, then x minus 1 equal to 2 divided by y. Then x equal to 2 over y, negative bring to the side become positive, plus 1. So multiply with y divided by y, then 2 plus y divided by y. So f inverse of y equal to 2 plus y divided by 2, and f inverse of x equal to 2 plus x divided by, wait a minute, 2y, okay, so 2 plus y divided by y, sorry, not 2, y, and also x here. Sorry for this mistake, careless mistake here. So y, and x. Okay. Then next, 2 plus x divided by x. Okay. Using the properties, never mind, I'll show you both f and f inverse of x equal to an x. Okay, so the first is f inverse so 2 divided by f inverse of x minus 1 equal to an x. So 2 equal to cross multiplied of this with an x. So f f inverse of x minus 1. Then f inverse of x minus 1. So divide by this one here, 2 divided by x. And then f inverse negative 1 bring to the side become positive. So 2 divided by x plus 1. Or simplify this, multiply with the x and x. So 2 plus x divided by x. Okay, same thing. Again, class, this method, okay, this method and this method, you can choose one of the method which you prefer then in your exercise or examination. Okay. Okay. Determine on domain and range of the function f(x). Oh, the question here. Sketch the graph of f and its inverse on the same axis. Okay, sorry, never mind. Okay, so now okay, so again, the purple ink represent the line of y equal to an x. Y equal to an x. Okay, now, class. As we know, well, look at this function, f(x) equal to 2 divided by x plus 1. As we know that the denominator cannot be equal to 0. Okay, the denominator cannot be equal to 0. So then, the line of x minus 1 equal to 0 and x equal to 1. This will be the, what do we call that? A line that graph with only approaching or getting closer and closer, but it won't touch or intersect the line at all. Okay, so with that with that explanation, x equal to 1 is an asymptote. Okay, a line where the graph is only getting close and close, but it won't touch because x cannot be equal to 1. If x equal to 1, then 1 minus 1 equal to 0. 2 divided by 0 is undefined. Okay, So now this is the line of x equal to 1. Okay, now this is the graph of f, okay, which is fx equal to 2 divided by x minus 1. Okay, now if I sketch using different colors here, so f inverse reflects with a function of f on the line with the line of y equal to nx. So if fx has an asymptote with x plus 1, then the f inverse, the function of inverse, has also an asymptote, but then for line of y equal to 1. Okay, so the same concept that I mentioned to all of you just now, that this line, the line that I'm going to write, that I'm going to sketch using the red ink, will not touch this line. Okay, the graph that I'm going to use this ink right now will not touch the line of y equal to 1, just like the graph of fx that will not touch the line of x equal to 1. So then I'm sorry for that. Okay, so I'm going to sketch this. Okay, there you go. That's it. Okay, this red line this red line represents the f inverse, and this line represents the fx. Okay, there you go. Okay, class, I suggest to all of you to, okay, might be so for some of the students, they know some other website that can help us to sketch the graph of this function, but then I do strongly suggest to you use the website of www.desmos.com. Okay, let's say once you sketch these two graphs, then in this website you can simply substitute, or we call fill in the function of fx and its inverse, then see by yourself. We call the position of the graph, and the graph of f inverse reflects with the graph of fx from, okay, we call between the line of y equal to nx. Okay, so what is the domain of this function? So class, what is the domain of this function? This is the domain first. So the domain of this function is from 1 to positive infinity, and the range, look at the graph of this blue graph here, starting from 1 to positive infinity, and this line will only approach or getting close to the x-axis, but it won't touch it. So it is from 0 to positive infinity. And what is the range of what is the domain of this of the f inverse? The domain of f inverse is the range of f, and the range of f inverse is the domain of f. Okay, so that's all for today. Thank you very much for your for your time, and hopefully because I do hope that this video really helps you to understood the content of this subtopic. So that's all for today. Thank you very much. Till we meet again. Hopefully that this video really benefits you and help you in your studies. That's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day till we meet again.